Precalc Chapter 5. Chapter 5 is all on trig identities, except for like one lesson. One lesson deals with solving trig equations, and it's the third lesson. I'm going to push that to the very end. So I'll probably push potentially, I haven't decided 100% yet, on lesson 2 as well, but we may do that one in the progression. But 1, 4, and 5 have all of the trig identities in it. There's about 4 to 5 blocks of trig identities in each lesson. These are the things that will eventually be on the back side of the unit circle. Now, I would not every day sit down and start putting these onto your unit circle because they're going to take up a lot of space. You may, for a while, write these down on a separate sheet of paper to kind of gauge how big or small they can be so you can fit all of them on there. If you make a mistake, I'm not allowing you to attach a separate sheet of paper. You need to do the whole entire unit circle and put all the information on the back again. Okay? So I'm not going to, allow several pieces of paper for every time you add a new block of identities. So these are pretty much the only notes you guys are allowed to use throughout the year. And then, of course, on your semester exam, you'll get to use the unit circle with all of these on there again, so you don't have to put them on your official note card.
So as seniors, we don't have to take that, right?
So this first set of
What is this for?
identities should be very familiar and not an issue. We've dealt with these before when we got introduced to the big three and then the little three. We have sine, cosine, tangent, and cosecant, secant, and cotangent. And we should know that they're just the reciprocals of each other. So there's a link between sine and cosine. Notice sine is 1 over cosecant, cosecant is 1 over sine. We will use that to our advantage. We should also know, because it's on our front side of the unit circle, that tangent theta is sine over cosine. That means cotangent is a reciprocal cosine over sine. And so, let's go into our problems. I want to be able to use the reciprocal and the quotient identities. Okay? To be able to say, if I know that secant of x is equal to 5/3, find the cosine of x. Now I think the first one, pretty straightforward. I should be able to say, wait a minute, secant, cosine, the reciprocals. If I know one of them is 5/3, that means the other one is 3/5. But if I wanted to show a logical progression, I'm going to start off with the secant. So secant of x is equal to 1 over, actually, sorry, I did this wrong last time as well. I started wrong. We're not starting with secant. You want to find cosine. So I'll start with cosine. Cosine of x is equal to what? Look above. It's 1 over the secant of x, right? And do you know secant of x? It's 5/3. So I can take secant out, replace it with its value of 5/3, and I get 1 over 5/3. I'm dividing by a fraction, so I flip and multiply. So it's 3/5, which is exactly what we said. It's a little bit more work to show it. Obviously, to show work, it takes work. But it at least allows us to see the progression from cosine to secant or vice versa to find our values. Now, part B. They give you cosecant beta equals 25 over 7. Secant beta is 25 over 24. Can you find the tangent of beta? Hint, start with tangent and switch it or convert it. So, what is tangent? What's tangent? It's sine beta over cosine. Now, I think everybody would agree with this, but the question is, do I have a sine and a cosine? Not directly, right? So I could stop right here and say, wait a minute, I technically do have sine if I do a little bit of work. Sine is just 7 over 25. Cosine is just 24 over 25. Well, then I can directly substitute those in for sine and cosine. So I'm quite happy about that. But then I got a complex fraction where I got fractions divided by fractions. So I take the bottom one, flip it, and multiply. So 7/25 times 25 over 24 cancels, leaves me with 7 over 24. That's awesome. That is one way to do this problem. Another way to do this problem is that what happens if I get to the point where I have sine of beta over cosine beta? What is sine according to the top?
Oh, you could do it 1 over cosecant.
Right. Because I'm given cosecant and secants, why don't I just change it to cosecants and secants? So this becomes 1 over cosecant beta over 1 over secant beta. And if I'm dividing by a fraction here, now I can flip and multiply. Which results in secant beta over cosecant beta. I'm just rearranging the problem. And we know secant. It tells us secant is 25 over 24 over 25 over 7. Which again means I need to flip and multiply. Cancels and leaves me with 7 over 24 again. So some people are like, well, I'm just going to do the first way. Well, maybe you don't see that way because you're given a secant and a cosecant. There are more than one way to do these. We ended up using the same ratios. We flipped them, we multiplied them because of complex fractions, and we got 7/24 both times. Perfectly fine. So you're seeing how we can use reciprocal functions to evaluate or solve for another one, given some ratios. It's pretty cool stuff. Next ones. These ones, I think, are probably some of the more important ones. Are the Pythagorean identities. Sine squared theta plus cosine squared theta is equal to 1. Tangent squared theta plus 1 equals secant squared theta. And cotangent squared theta plus 1 equals cosecant squared theta. There are some important things that we are going to have to know. What does it mean to be sine squared theta? That means sine squared theta is the same thing as the quantity of sine theta squared. The reason why, or they chose not to write it as the sine of theta, the quantity squared, first of all, I got to have to put parentheses in there. Second of all, there are times where you guys get a little lazy, you forget to put the parentheses, and now it looks like sine of theta squared. And that means you're squaring an angle. We don't square angles, so therefore, that's a no-go. So we move it on sine, so we know it's the function squared, not the angle squared. I think all you have to do is memorize the first one, if you're going to memorize one. And hopefully by the end of this course, you guys will have that memorized. Because the other two are made from that one. This one, or every single one of these, I guess to say, should have a function squared. So remember, I could technically solve any one of these, sine or cosine squareds, tangent or secant squareds, things like that, for one or the other. I can add or subtract, I can take the square root, that kind of things. So anytime I'm working with a problem and I see a trig function squared, I should know that there will be a possibility of taking that squared function out and replacing it with some other function. 4/4 for $1. I'm actually able to swap them at any time. They have the same value. So the question you might be asking is, how the heck do I get a tangent squared plus 1 equals secant squared theta from our problem? The key is, how do I get a secant again? It's 1 over cosine. In this case, 1 over cosine squared. So, watch this. If I take all three parts and divide it, it's like I'm dividing both sides by cosine squared theta. What's sine divided by cosine? So therefore, sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared? 1. And 1 over cosine squared is secant squared. We just built the second one. This one over here, I want to get a cosecant squared, so I'm going to divide up both sides by sine squared. And sine squared divided by sine squared is 1. Now granted, they moved it in order, so it's 1. Cosine squared over sine squared will be cotangent squared. And 1 over sine squared is cosecant squared. So each one of these other two are just a modification of the first one. So you remember the first one, which is sine squared plus cosine squared equals 1. Wait a minute, guys. Think of this. That's Pythagorean's theorem. A squared plus b squared equals c squared. Go to your unit circle. The hypotenuse is 1. That's r. That's 1. Okay? Sine and cosine are actually your x's and your y's, aren't they? Which is your length and or one leg and the other leg of your circle. It's x squared plus y squared. Because x's is cosine, y's are sine. So it's just the same thing. It's just Pythagorean's theorem with that point in mind of your triangles on the unit circle. Cosine comma sine. So, how can I use the Pythagorean identities to solve for the value of cosecant theta and tangent theta when you're given the fact that cotangent theta is equal to -3 and cosine theta is less than 0? Why are these things important? They're your restraints. Cosine, you know, is negative, and cotangent is negative, which means also tangent is negative. So when is cosine and tangent both negative? You have to go back to, all students take calculus, which quadrant? Which quadrant is cosine negative? Which two?
No, 2 or 2, 4.
2 and 3. Cotangent's negative or tangent's negative in which quadrants?
Tangent.
1 and 2 and 4. So where would those overlap?
2.
2. So I am in the second quadrant. So cosecant will be what value? What's the cosecant? What's the sine value in second quadrant? Positive. So the cosecant is positive. Tangent in the second quadrant is
Negative.
negative. So when we find these, we should know what kind of label to put on their positive or negative signs. Okay. If I want to solve for cosecant, look above. Can't I use this one? Because it has cosecant and it has a tangent in, or cotangent. I know what cotangent is. It's -3. So cosecant squared theta is equal to cotangent squared theta plus 1. Cosecant squared theta is equal to, what's cotangent?
Cotangent is
Isn't it -3? And I could square that. What's that? 9 plus 1, which is?
10.
And then to solve for cosecant, take the square root to get rid of the square. Technically, theta would, not theta, but cosecant theta would equal plus or minus the square root of 10. But how come I don't have to worry about that? Because we said cosecant should be positive. So we're going to say it's the positive square root of 10. Done. I just used the identity, plugged in the stuff I knew, solved for it, called it a day. Interesting. I want to know the tangent. Now, this one's kind of interesting because if you know the cotangent, you just have to take the reciprocal and you get what? 1 over -3 or -1/3. That is the tangent. And it should be negative because I'm in second quadrant, so therefore that's true. But if I wanted to show some work here, you can use the fact that going back to the 3 of them on top, if I chose to try tangent squared theta plus 1 equals secant squared theta, because there's tangent, and if I want to just take the square root like last time, I would have to know what secant is. Do you know what secant is according to any of these? I know cotangent's -3. Oh, I know cosecant is -10. But I only know that cosine is less than 0. That's not enough information to actually state what the value is. I think I'd have to go back to this one. Because I know cosecant. It's right there. And I want to find tangent, but if I find cotangent, I can take the reciprocal. So I know I'm just kind of rehashing some work here, but wait a minute. Could I take that top third equation and switch it around a little bit and call it cosecant squared minus 1? Can I just take the 1 from this side and subtract it from both? And then I should be able to, at the end, just take the square root of the whole thing. I'll do that in a little bit here. What's cosecant? What's cosecant theta? We just had it here, square root of 10. And if I square square root of 10, I get what?
10.
So therefore, it ends up being 10 minus 9.
Or 10 minus 1 is 9.
10 minus 1 is
9.
9. And if I take the square root, both sides,
3.
it's 3, but cotangent had to be
Negative.
negative because it's plus or minus.
Yeah.
So cotangent theta is equal to -3. I don't want cotangent, I want,
Tangent.
so therefore it's -1/3.
Third.
Take the reciprocal. Or cotangent theta is 1 over tangent. Or tangent is equal to 1 over cotangent, so therefore I can take the reciprocal. And we have an answer. Some crazy stuff. It makes sense if you logically put your steps down. If you try doing a lot of this stuff in your head, you're going to have some issues. Do the same thing with the next one. The next one I want you to solve for cotangent x and secant of x, but all you're given is sine of x is 1/6, while cosine x has to be greater than 0. Try this one on your own for a second. Which of the three am I using to find cotangent? I think the last one, right? So cotangent squared x is equal to cosecant squared theta minus 1. I just kind of rearranged it just a little bit. Okay, so if that's the case, cotangent squared x is equal to, now I could change it right now as in going up here. I should be able to make this leap. Actually, you should call those x's, right? Sorry. I should be able to make the leap and say that this is 6, right? Because there's reciprocals.
Yeah.
Or I could, instead of writing it as cosecant squared x, couldn't I write it as 1 over sine
Yeah.
squared? I think it'd be easier to switch it first, because now it just becomes 6 squared minus 1, which is 36 minus 1, which is 35, and then at the end take the, and you end up with square root of 35. Now the question is that supposed to be a positive or negative? Because I took the square root again. What's sine? Positive. Cosine is? So if sine and cosine are both positive, what quadrant are you in? First. So therefore, the tangent or cotangent will also be positive. You got her. Now, take a look at this. Now that I know cotangent, could I go back and solve for secant? Or, I know sine. Could I use the first one to solve for cosine and then take the reciprocal? So there are several different ways to get there. And if it doesn't get there, then maybe you should try a different one. This is like a chess match. More than one way to win the game. And you always should be thinking 3 to 4 moves ahead. If you don't know how to play chess, then play checkers. So, which one do you guys want to use? First, second, or third?
Can we do the
A second.
Second one, okay.
Because we can change the color.
Secant squared x equals tangent squared x
plus 1?
plus 1. So secant squared x equals, okay, maybe I should take this part and change it to a tangent. Maybe I'll do that first. Is that okay? So that means that tangent of x is 1 over the square root of 35. So that means this is 1 over the square root of 35 squared plus 1. Or did I do that wrong? I did it right. Okay. Ooh, how do I square a fraction? Top and? So secant squared x is equal to 1 over 35 plus 1.
Yeah.
What's 1? One is in terms of a common denominator, it'd be 35, 35, right?
Yeah. So it's 1.
So what's 1 plus 35?
Oh, 36.
It'd be 36 over 35. And then to solve for secant itself, I need to take the... Again, I'm in which quadrant, though? I'm in the first quadrant. And if I square root a fraction, it's the same as squaring a fraction. I take the top and bottom. What's the square root of 36?
6.
Over?
There is square root of 35.
Square root of 35. Now, if I was to leave this in the most appropriate answer, I would rationalize that by multiplying the top and bottom by square root of 35. I'm not going to worry about that because right now I want you to progress through it and actually be able to show me the ratio. But if you were to look in the back of the book for the right answer on any of our problems, you would probably have to rationalize that. If I was going to use that number again, I'd probably have to rationalize it. Questions, guys? Okay. One of the last things we're going to talk about are cofunctions and odd-even identities.
Where do you write all of that down?
It's all in your book or all on the planner here. So, the biggest thing, looking at this, is that if I was standing in the front of the room looking at you guys, I would ask you, everybody, your right is my left. Right? That would be the case. Only because we're looking in different perspectives. Doesn't make it wrong or right. But remember that if I'm at the angle at the bottom, its opposite is y. Its adjacent is x. If I'm up here at beta, then opposite is x, the adjacent is y. By looking from a different perspective, we were able to find same values using different ratios. Think of this, guys. What's the sine of 30? Everybody should know it. Sine of 30? You guys got your unit circle, so sine of 30 is half. What's the cosine of 60? Half. What's the sine of 60? Square root of 3 over 2. What's the sine of sine of 60? Or cosine 30, sorry. Cosine 30. Square root of 3 over 2. They're the same value. Sine, cosine. Tangent, cotangent. Secant, cosecant. They're co-functions, guys. This works for any angle taken from pi over 2. So, sine of any angle is the same thing as cosine of its cofunction, which is 90 minus the angle. So if I took sine of 1 degree, it's the same thing as a cosine of 89. They have the same values. Think about it. Your unit circle only has 5 values. 0, 1, square root of 2 over 2, square root of 3 over 2, and 1/2. And it's reused over and over and over again. That's why we use those ones. This is using pi's over 2, which is in radians. You could substitute that with 90. And so just like the quarter idea for $1, if I were to see sine of 30, I can substitute that for a cosine of 60, and I'm fine. Tangent of 30 is the cotangent of 60. Secant of 30 is the cosecant of 60. They're interchangeable that way. All because of the different perspective of the angle or triangle you're looking from. The other one is the bottom, even and odd. I say you only have to really worry about that top layer, as I missed some of them. The top layer, because cosecant and sine are the same thing, just reciprocals. They're both the same type of function. These are even and odds. So, do you guys remember what it means to be even or to be odd? If I said f of x equals x squared, and I put in a negative x, what happens with that negative? It goes away, right? Because a negative times negative essentially leads us back to the original function, yes? That is even. if I let, say, g of x equal x cubed, and I say g of negative x, well, g golly, a negative used 3 times is still, and that just means it's the opposite of the original function. That is considered odd. So we call this one odd, and we call this one even. So when it's even, a negative on the inside disappears. It's a disappearing act. But if it's odd, a negative on the inside gets pushed to the outside. Take a look at what happens with sine. Sine of a negative angle is the same thing as a negative of sine of the positive angle. Sine of 30 is, what again? It's a half. Sine of negative 30? It's a negative 1/2. Because 30 and negative 30 have the same reference angle of 30. But if I move to the 4th quadrant, sine has to be negative. So it's a negative sine of 30. Tangent does the same thing. Tangent is also odd. So if you have to or want to, put odd next to the sine, put odd next to tangent. So if there's a negative inside of tangent's angle, or on the angle, move it up front, turn it positive. I'd rather work with positive things. Positive students than negative ones. Cosine, on the other hand, is what we call even, because when I take the cosine or the secant of a negative angle, the negative just disappears. You don't have to worry about it anymore. The cosine of 30 and the cosine of negative 30 are the exact same value because you're moving in the same direction positively. We got one last problem. It's got to put both of these together. Do we have all this information that we want here? Here we go. You ready for this? Use cofunction and odd-even identities. If you are given the fact that sine of x is equal to a negative 0.37, can you find the cosine of x minus pi over 2? Now we're not in degrees, we're in radians. Sine of some radian angle is equal to a negative 0.37. That's interesting, it's good to know. So when you're given something that you need to find, the biggest suggestion would be start with that thing you're trying to find. So in this case, cosine of x minus pi over 2. And try to change it into known quantities. Doesn't that look really close to one of our identities for cofunction? Let's go back a slide here. Isn't that really close to, let's see, this one?
Yeah.
Or this one right here, that top one.
Yeah.
Cosine of pi over 2 minus theta, or x. So wait a minute. This one says pi should be first. Pi over 2 should be first. Is it first here? No. Can I change that order? I don't see why we couldn't, right? They're just added, or subtracted, right? Added. So cosine of a negative pi over 2 plus x. Is that the same thing now?
Yeah.
Not really. Go back to that original one.
It has to be positive.
The pi over 2 should be positive,
Yeah.
and the x should be.
Negative.
So that means there's an extra negative laying around in there. Can you take that negative out? Factor it?
Yeah, you could take negative 1 out, couldn't you?
Right. So could I take a negative 1 out, and that becomes a positive and a minus? And since cosine is even, that negative actually will disappear. It's an even function. So therefore, it's equal to the cosine of pi over 2 minus x, which is the cofunction to what other function? Sine of x. And do you know the value of sine of x? It's a negative 0.37. Guess what the answer to cosine of x minus pi over 2 is? Negative 0.37. It's amazing how they gave you the answer and you just had to verify it, basically. That's what they're going to do to you in these problems. A lot of the times the answer is going to be right in front of you. You just need to make the connections on why it works. Homework. Day 1 of 5.1, page 317, 1 through 19, every 3. Have a great day.